building an offline capable chat application. We'll be using Supabase chat tutorial app as a starting point, and then we'll be integrating PowerSync into that app. This tutorial will be targeted at mid-level developers. Tools that we'll be using, I've got my console. I'm using Warp on macOS. We've got VS Code with a Flutter extension installed. I'm going to be using 2 devices. I've got a physical Android device on my desk here that's easy to toggle airplane mode on and off, and I also have iOS Simulator running. I've also signed up for a Supabase account and a PowerSync account. These are all the tools you'll need. In terms of the flow for the tutorial, like I mentioned, we'll be using the tutorial chat app. I already have 2 users set up, Kobe and Philip. The app itself has a messages and a profiles table. I've already set those up on the Supabase side. And the first thing we'll be doing is getting this app up and running. And we'll then notice that the app doesn't actually work well offline. And at that point, we'll add PowerSync. That consists of 2 steps. Firstly, configuring the cloud service and then incorporating the SDK into the client-side Flutter application code. Okay, let's go ahead and run the chat app. So the code for the chat app is available here. It looks kind of long, but it's not that long. I recommend doing this. But unfortunately, it's not really easily available. So I've created a GitHub template that you can use as a starting point for your repository. And let's go ahead and call this Supabase PowerSync chat. Let's get ready to clone this repo. Okay, there it is. And then let's cd into it and open it up in VS Code. First thing we got to do is just copy and rename the .env.template file. And this is where we'll be storing our secrets so that we don't have to commit them into GitHub. So to get the project URL, you go to Settings API in Supabase. Go ahead and copy that value. And to get your anon key just below that, paste that in and save that. Okay, that is all the setup needed. We can go ahead and run it now. But first, let's go ahead and have a look at the code. Obviously, it's shouting a bit, but we can go ahead and install the dependencies, and then VS Code should be a little bit happier. So the first thing we do is we load that .env file that we just created. We then initialize Supabase using the URL and the anon key and run the app. The app itself starts off here with a splash page. The splash page checks whether the user is currently logged in or not. If the user is not logged in, it routes the user to the register page. Otherwise, it goes straight to the chat page. The register page lets you sign up with username and email, but there's also a button if you already have an account, which takes you to the login page. The login page has a username and email field. The chat page itself opens up a message stream from Supabase, and this binds to a list widget, which streams messages. There is a send button in here, which calls a submit message function. And what that does is it inserts a row into the messages table with a user ID and the text content. All right. So with that, let's go ahead and run this. We can run it on the iOS simulator. Open another console. And let's run it on an Android device too. This does take a few seconds. Okay, there we are on iOS. I will log into the iPhone as Philip. And I will log in on Android as myself. Cool. And we can see messages flowing back and forth. Now, if I go ahead and put the Android device into flight mode by disabling Wi-Fi and data, you'll see that the app actually breaks. In addition, if we force quit the app and try to relaunch it, okay, it didn't actually force close. Got to swipe it up in a specific way. It close all. There we go. Users cannot actually load the app while offline. So let's go ahead and restore Wi-Fi. That will eventually recover after some time, but let's just go ahead and open it up again. Okay, and this is the starting point for the tutorial. Next up, we're going to configure our PowerSync cloud service. The PowerSync cloud service keeps your devices in sync with your Postgres database. You can read up more about it on our website, but we go ahead and sign up or sign in. If you've already got a PowerSync project, you can click on the icon in the top left, and that'll take you to the admin portal where you can go ahead and create a new project for this tutorial. Okay, so we're going to create a new instance as the first thing. We'll give it a name. Over here, we can change our region to the EU. We've got a couple of other regions available as well. These are just the two that we've got wired up to the UI at the moment. You can also enable Supabase authentication. Okay, here we create our connection. This is literally our connection to Supabase. So we head over to our Supabase dashboard, settings, database, URI, and we copy the connection URI. Paste that into the URI field over here. Next up, we paste in our password. Allow querying data. What this does is it enables us to run SQL queries from our PowerSync dashboard. If, for example, you're going to be sharing the dashboard with other members of your team and you don't want them to be able to query the data, you can disable that. Okay, we test connection here and we hit save. Okay, very good. The instance is currently being provisioned. It does deploy some pods in our Kubernetes environment and configures them and sets them up and stuff, so that does take a little bit of time, but we'll just sit tight and wait for that to happen. Okay, excellent. Our instance has completed deploying, and we can actually see here that we've got our tables in Supabase visible, and we can take a look and see that, okay, the connection between the PowerSync cloud service and the Supabase database is successful. The next thing we got to do is set up our sync rules. There's a link to the docs here, but essentially sync rules are customizable rules which define how to partition your Postgres data into data buckets that get downloaded to your user devices. So these are just some examples which we'll go and clear out. Now, typically what you would do for a production app is to have two types of buckets. You would have global data that is shared across all users, like perhaps some reference tables. And then you would have per user data, which basically takes the user ID in the authentication token and pumps that into a query, and then the resulting query defines the data bucket. But for this tutorial, we're simply going to sync all profiles and all messages to all users. Now we can validate that against the database, perform some basic checks, everything checks out. At this point, we're going to deploy. Deploying sync rules at the moment does recalculate everything. We will be implementing incremental sync rule reprocessing in the near future, but as of the recording of this video, that is not implemented yet, so this does take another minute or two. Okay, awesome. That has finished deploying, and we can also save changes to our sync rules, and you can wire this up to your GitHub or Azure repos repository and store your sync rules there. But for now, we are done configuring the PowerSync cloud service. Now for the final and fun part. We are going to wire up the Flutter PowerSync SDK into our app. Broadly speaking, this consists of, we'll install the SDK, we'll implement our client-side schema, we'll then implement helper models. There are two methods we need to implement, one for sync and one for auth. And then we'll modify our UI to hydrate and connect to the local on-device DB instead of using the Supabase APIs. For this section, we're going to be in our trusty VS Code. If you recall, here's our Supabase chat app. So the first thing we'll do is simply install the SDK. Okay, while that finishes installing, we will create a new file in our lib folder where we will be placing, just separating concerns and having a bunch of our PowerSync specific code over here. So let's first go ahead and import that. I assume it's finished. Yeah, it's finished. Okay. We're going to implement two main things here. The first is a call to open the database. So let's call that open database. The second is we need to implement an instance of what's called the PowerSync backend connector class. We can go and have a look at the docs here on the API reference page. The backend connector really does two things. It gets credentials for connecting to the PowerSync cloud service. That, of course, is used to download data as we defined in the sync rules. But the other thing the connector does is upload local changes to your backend application server. So those are the two methods that we'll be implementing. Another place to look at is on our docs. Under client-side setup, we need to instantiate the PowerSync database. That's really what we'll be doing in this open database method. And then integrating our backend, we'll be implementing fetch credentials and upload data in the Supabase connector class. Okay, so we'll get to the, let's, I think, start with the some of the boilerplate in the backend connector implementation. So we'll call ours a Supabase connector. And so there really are those two methods that we need to override. There's upload data and then fetch credentials. So all you need to do is implement fetch credentials, and the SDK will take care of connecting to the cloud service and downloading all the right data as per sync rules, retrying if the network fails, etc., etc. So for this implementation, we can use Supabase authentication. If you recall, we enabled Supabase auth in our dashboard. At the end of this method, what really needs to happen is we need to return an instance of PowerSync credentials. So if you go have a look here, fetch credentials returns PowerSync credentials. So we need to return. That takes two parameters. The one is the endpoint, the other is the token. To get your endpoint, we can go and fetch it right here. If you right-click on your instance, click Edit, this is your endpoint over here. You can copy that value and paste it there. Now, in order to get the token, that really is just the Supabase access token. But, so it's pretty much something like Supabase of course, we need to import the Supabase package, the Supabase Flutter package. So let's go ahead and do that. Supabase Flutter, that's this one over here. Okay. It's then the instance namespace. There's a client. Inside client is auth, and inside that is current session. So that is just the token that we return there. Okay, it is complaining. This is actually async because that's an async method. Cool. Okay. It's actually, yeah, it's current session, but there's an access token on it. There we go. So there are potentially some nulls that we could run into here. So what we'll do is we'll extract the session. Then we'll do some null checks on the session. In this case, this means that the user is not actually currently logged in, and we simply return a null. So now we can extract that token, and we're good. So the SDK, as a reminder, is going to be calling this to determine whether it is able to download data from the cloud instance or not. Upload data is a little bit more complex. We'll circle back to that one in a minute. I think for now, let's go ahead and implement this open database method. All right. So to get a global handle to our PowerSync database, what we implement up here on this scope is we say, okay, late, so it's going to be initialized later, and there it is, PowerSync database DB. And then essentially what we want to do over here is we want to initialize it using the constructor, and this constructor requires a schema, that's a client-side schema, and then a path to the actual file in the app. It's nice to just abstract the path logic a bit, so we can implement a method called getDatabasePath, and that will be a future. It'll return a string. It's an async method. And essentially what we return here is appending the current application directory, so we'll just call that dir.path, with the file name of our database. So what's cool is you can actually work with multiple PowerSync databases by simply having multiple of these paths if you ever wanted to do that. So that dir is simply a function call to get the current, I think it's something like this, support directory. See if it can detect that. No. Okay. Yeah, so that is in a package called path. And specifically there's path.dart, and we also have another one called path provider, this one. Okay. Cool. And so then we can simply call this method here with adding an await. Okay, for the schema, we're going to define our schema locally. So we'll create it in models, new file, we'll call it schema.dart, and import the PowerSync package. This file will essentially be the application level view onto the underlying SQLite data. So we'll define our schema as a const, and then we'll actually switch to our PowerSync dashboard where we can use the schema generator. So this uses your sync rules to generate client-side schema. Right-click and on the instance. Here you can choose your language. We select Dart, and that uses our sync rules to, based on our Postgres schema and the sync rules, generate our Dart schema. And there you have it. We have now defined our local client-side schema. Okay, we'll go ahead and import that schema. And now our open database call is happy. The next thing that we do is we initialize the DB. The final endpoint that we're aiming for here is calling the db.connect method, which you will see over here. This connect method is what we want to implement. But first what we'll do is we'll call the initialize method. We then also want to move our Supabase initialization code here. So let's go and extract that. Pull in the .env package. Remove it from here. And here we were going to call PowerSync.open database. This is back in our main.dart file. Okay. So we only want to call that connect method if the user is actually logged in. So in order to determine whether a user is logged in, we will implement a helper method called isLoggedIn. Okay, so if the user's current Supabase auth session has an access token, then we will return true. Now back here, we can check whether the user is logged in. Like I mentioned earlier, what we're aiming for is calling the db.connect method. That takes a connector, which is an instance of the Supabase connector, which we could instantiate here. But we're going to move it up because for reasons we'll see later, we're going to need to reuse that, and we'll call that the current connector. And so over here, what we'll do is we'll set current connector, so the user is logged in, and we inject our global reference to DB over there. At this point, we can connect using the current connector. Let's see what the issue is here. Of course, we need to define that our connector takes a DB as a parameter. So we'll head back here, get ourselves a handle to DB, and then call the constructor using the start shorthand. So that basically says if we get a DB parameter into our constructor, we set this DB to equal that. Okay, this is all very well for when the app starts up for the first time, but the auth state of a user can change throughout the app lifecycle. Users can sign in and out, the JWT token can expire, etc. So there's a little bit of boilerplate here, but essentially what we're going to do is we're going to listen on this client, and there's a method called on auth state change. We can listen, and then this basically gives us some data, and we can implement our own async method here to react to auth state changes. We pull out the event here. That constructor isn't accurate. It's actually inside data.event. And then we can check. So event can, we've got basically three things that can happen. The user can sign in, the user can sign out, or the token could be refreshed. So basically it's if event equals, there's this enum auth change event dot, let's do signed in, else if they signed out, we'll have some logic there. And then otherwise, if the token refreshed, we'll have some logic there. Okay, I'm going to remove those comments because the code is pretty obvious what's happening here. So if the user is signed in, everything is good, and it's essentially the same as is logged in logic. So we set the current connector to Supabase, injecting the DB. Okay, and at this point we can connect our database. This takes the current connector. We know that's not going to be null, otherwise throw a runtime error, so we hit an exclamation mark there. Okay, if the user has signed out, essentially what we want to do is set our current connector to null, and that's why we made it nullable up top. And then we want to disconnect our database. Okay, if the token has refreshed, we can simply call this method here called prefetch credentials. And that basically triggers a token refresh for PowerSync. Okay, and that is the end of our open database method. Like I mentioned, the last thing we got to do here is implement the upload data method. But let's first go back and have a look at our UI and how we're going to be wiring things up. So in terms of wiring things up to the UI, that's all going to happen in our chat page. My approach typically is I just search for usages of the from method from the Supabase Flutter API. So we've got our stream of messages over here. We've got loading our user profiles, and then we've got the insert to create a new message. So those are the three that we're going to be implementing. Okay, so implementing a stream in PowerSync is done using the watch method, which you can find in the documentation by looking at the PowerSync database class, and on that is a watch method. The watch method executes a read query every time the source tables are modified. Okay, so we'll put this method in here in our message model. We need a reference to that global DB object that we defined here, so we'll import this file. And then we'll create a method called watch messages. That takes, that takes a user ID as a parameter. And it's also a future, it's a stream with a stream consisting of a list of messages. And then at this point, we want to return that db.watch method. This wants a SQL statement that it's going to execute. Again, read-only. In order to define your SQL, you use your existing ORM statements as a guideline. So we want to select everything from messages, order by created at, and then we're going to iterate through records, injecting this user ID parameter. So we go select star from messages, order by created at, descending. And then for each of those, we want to call the map method. Now, previously on the chat page, this calls the from map method. But what we actually want is we want to instantiate an instance of a message object from a database row. So we go and define a factory method called message from row, and this is going to take a SQLite row, and for that we're going to import from the PowerSync package some SQLite helpers there. And so here we have a SQLite. Let's get this I imported the right package. Yeah. Give it a name. Cool. There we go. Okay. So we're going to get the database row, but then we also are injecting that my user ID from the tutorial. Okay, this parameter here is called row. Now we want to instantiate that message object. We need to fetch the values from this row parameter. So what I typically do here is just a bit of text editor sorcery. Okay, wrap up this last one. Get out of multi-cursor mode. Cool. So here, these actually need to match up the names of the columns we gave in the schema. And this is the profile ID field. Great. Now for our results, we can return mapping each row in the results becomes a, we use our from row method that we just defined. And that uses row and my user ID. Of course, we need to cast this to a list with a false on the growable. We make this a static method so that it can simply be called. And let's have a look at what it's complaining about here. Oh, we need to give our function a name. Watch messages. Cool. All right. So now we can come and wire this up. In our chat page, we have the message stream defined up there. We can delete the Supabase code, and we can simply call the static method we define. Watch messages, injecting our own user ID. Great. One down, two to go. The next one is simply selecting from the profiles. So let's go ahead and implement that select for the profile. We'll implement a method called, again, we need to implement that factory method from row. Takes a SQLite row again. Let's pull in SQLite. Let's pull in our PowerSync. And it's the same paradigm. Like I mentioned, this is kind of once-off, which will definitely build some tooling around in the future to help make this process simpler. The main thing is to remember to make sure, I selected too many. Okay. Yeah, we just want these here. Yeah, it selected one too many up there. I should only, there we go. Cool. Like I said, the main thing to remember is that it matches the schema that you defined. So that lets us instantiate from SQLite rows, and we'll implement another future method that returns a profile called, let's call this find profile by ID, which takes a string ID. It's an async method. And then there are a couple of methods on the DB object. So in our case, we want to do one of the get methods. There's get, which selects a single result. There's get all, which selects a result set. So we're going to use get because it's just the single row that we're looking for. This is now, the query is, okay, it needs to be a string. We're going to select star from profiles where the primary key, and this is, we just use parameterized SQL here to kind of prevent SQL injection. You don't have to, the blast radius of SQL injection is very limited here because this runs against the local database and not your Postgres. But it is, best practice to always use parameterized SQL statements. And then we call our from row method, injecting this result row. Of course, we want to wait for those results before instantiating. Cool. Now we can head back to our chat page, and then we can pretty much set our profile directly. We don't have to extract it from data. And so we can call that find profile by ID method, which was taking let's see, what was that taking as a parameter? This profile ID. Okay, so that is already injected here. Cool. So yeah, find and profile ID parameter. This needs to wait. All right. Okay. Cool. 2 down, 1 more to go. The last one being creating messages. So let's see. That should be around the submit message button. Just hide my get lens. Here we go. Insert. So this is going to be a helper method on the messages. And so we'll call this one create. This doesn't return anything. Again, it's a static method. This basically takes 2 parameters. Again, you can use your current as a reference, the profile ID and the content. So we take our profile ID and the content. It's an async method. And then to mutate data, there's the execute call. There's also execute batch, but execute is used for insert, update, and delete calls. So we go db.execute. This takes our SQL. And so in our case, we're going to be inserting into the messages table. The syntax of this is column names, values, and then this is parameterized with an array of the values. Our columns are ID, created at, profile ID, and content. Now for values, we want to generate a new UUID, so we can use the native UUID method. For datetime, we can use that, and then we've got our 2 parameters, profile ID and content, and these are just passed in from the top level. Okay. And with that, we can replace this call with our call to create. So that would be message.create, which is my user ID, and content, I believe, is the text content of the message from the... Okay, cool. All right. So now that we have a bit of familiarity with how things work, we can come back and implement this upload data method. With upload data, there are essentially 2 options. Again, everything from the PowerSync database class. We can get a CRUD batch, which gets a batch of CRUD operations to upload. or we can, so that literally gets it, batch by batch, or we can use get next CRUD transaction. Remember, the upload data method gets called by the SDK whenever there is data to upload, whether the device is online or offline. And if this call throws an error, then it's going to be retried periodically. For this, we'll use get next CRUD transaction. If there's nothing in there, we can just return. If not, we know that there's something to process over here. Basically, we are going to iterate through every operation in that transaction.crud list. If you go and have a look at what gets returned, it's a CRUD transaction. There's a CRUD object, which is a list of client-side changes. So we iterate for every operation in transaction.crud. Now, essentially, we want to cater for 3 types of operations here. We have our put. These map to Supabase upsert. We have our patch. This matches to Supabase's update. And then we have delete, which matches to delete. So the first thing we do is we extract the table name. Now we want to op.table is a property, but we want to set the Supabase client to be that table. So let's first get a handle on the REST client. So that would be supabase.instance.client.rest. We set this handle to be the from syntax, but instantiating the table. So this gives us a handle to the from function in the Supabase client. Okay. Now we're basically going to compare to the values on this update type enum. So we had, okay, put not table, it's operation. Cool. So we had patch. Okay. So here we want to call table.upsert. Here we want to call table.update. And here we want to call table.delete. Upsert takes a data payload, which we have to create. And we set all right. That is that. For patch, we're going to call, we first need to call that equality operator. That takes a second parameter here, EQ. The payload is going to be the data again. The column we are updating on is the ID column. Delete has a similar syntax. Again, matching on the ID column. Okay. Now, once we've iterated through all of those, we can actually complete the transaction. That means that all the operations were successfully applied against Supabase. Now there are a couple of errors we can run into here. The biggest one being Supabase's Postgres. So we'll monitor for those. Now, if there's a defined list of error codes, which I'll go ahead and import here. You can find this in our demo app. Now this, so we can simply check whether our error code has matched any of those regexes defined in the fatal response codes. That's checking the error code. Let's get my in this case, instead of blocking the rest of the upload queue with an error, we pretty much discard the rest of the transaction. So we simply just mark it as completed. However, it is important to note that if protecting against data loss is important, this typically requires some. This typically indicates like some bug in your app, and so what you would rather do here is, instead of discarding the data, you would save the failing record somewhere else. You can work with data locally that doesn't have to sync, and save them there, or even send the failed records up to the server in a special like failed table, so that perhaps your support team can take a look at it, and you may want to notify your end user. But for the purposes of this demo, we'll just continue. And then, yeah, pretty much any other error, we'll just rethrow that. Oh, right, here, yeah. Okay. And with that, we should be able to run our app. Let's relaunch the apps here. Okay, let's put the Android device into our airplane mode again. Okay, we are now disconnected. Send the other user a message. Now we'll emulate connectivity being restored. Does poll with a bit of backoffs, and we're going to wait. Okay, now Wi-Fi is restored, and there you can see that those offline messages were queued for writes, and then the updated data was received from the server. And there you have it. We can, at this point, basically take a look at all the files we changed. But to recap, we implemented schema, which is a new untracked file. We implemented PowerSync.dart, essentially our Supabase connector, which extends the PowerSync backend connector. Inside the connector, we had two important methods: upload data and fetch credentials. And then we implemented some helper functions in message and profile that we could use to wire up our UI to the on-device database.